What if everything we know about the universe is just a convenient version of reality? What if the most solid laws of the cosmos are actually based on fragile assumptions? We're used to thinking that we live in an understandable and predictable universe, that stars are born on schedule, galaxies follow rules, and the speed of light is an unbreakable limit. But as soon as we look deeper, the familiar picture starts to fall apart at the seams. Modern telescopes don't just observe space anymore. They ask it uncomfortable questions, and sometimes they get answers that don't fit into textbooks or even common sense. Giant stars, galaxies that are too old, impossible distances, and speeds that humanity is not ready for, neither physically nor technologically. Today, we'll talk about boundaries. The boundaries of size, time, and speed, about where human understanding ends and real space begins.
The starry sky is one of the most popular objects for contemplation, especially beloved by lovers and astronomers. At the same time, it holds many mysteries, because the billions of twinkling fireflies are actually gigantic stars and even entire galaxies. If there was a mythical creator who made the universe, he definitely had a fascination with gigantism. After all, as soon as you leave the boundaries of Earth, among the cold darkness of the vacuum, you encounter the giants of planets, and then stars that are many times larger than our sun. That's what we're going to talk about now. Armed with telescopes, let's try to lift the veil of cosmic darkness and take a closer look at the stars that are rightfully considered the largest in the observable macrocosm. Before we reveal the list of the top 5 whose sizes inspire awe, let's briefly go over the parameters of our own star. After all, everything is understood by comparison. So the Sun is a yellow dwarf located on the main sequence. The total lifespan of the star is 10 billion years. But half of that time has already passed, so we still have 5 billion years left. The diameter of the Sun is 1,391,000 kilometers, which is 109 times the Earth's diameter, and its mass is 332,946 times greater than Earth's. At the moment, our star, along with the entire planetary system, is making another orbit around the center of the Milky Way, located 26,000 light years away from it. At the same time, a galactic year for us lasts about 250 million years. Impressive, isn't it? But no matter how big and hot our star is, space is full of blazing monsters of much more frightening size. If you want to take a look at them from a safe distance, then arm yourself with curiosity and healthy skepticism. Let's go. Mutsifea, 5th place. Let's start small. Although it's hard to call this supergiant, located 5,255 light years away in the constellation of the same name, small. The star is 1,420 times larger than the Sun and 60,000 times brighter. It's strange that its surface temperature doesn't exceed 2,700 kelvins, while the Sun's is 5,780 kelvins. The radius of Mutsifea is 1.7 astronomical units. Therefore, if it appeared in place of our Sun, the fiery hyena would engulf all the planets, up to the giant Jupiter. Let's say more, it could easily swallow 1 million suns, just to give a rough idea of the scale of this star compared to our pygmy sizes. Imagine a 4-centimeter golf ball, that's us, and next to it, 2 Golden Gate bridges placed together. KAYWAI of Cygnus, 4th place. KAYWAI of Cygnus is spinning 5,153 light years away from the Sun. The hypergiant contains 1,420 radii of our star, while being 25 times heavier and 1,100,000 times brighter than it. It's hard to imagine how unimaginable these numbers are if we can't even look at the Sun without dark glasses. 6766 Centauri, 6X Sagittarius, and Westerlund 1, 26, 3rd place. The honorary bronze is shared by 3 giants located in different constellations. 6. 766. Centauri or Harvard Revised. 5171A, as it is also called, is located 12,000 light-years from Earth, and its radius is 1,400. In addition, 6766 Centauri is 39 times heavier than our star. The hypergiant has a smaller companion, Harvard Revised 5171b, with which they literally orbit in an embrace. The second participant is Westerlund 1-26, a red hypergiant. In the distant constellation of Ara, it would take at least 11,500 light-years to reach it. The minimum number of solar radii that this giant star can contain is 1,530. Its luminosity is 380,000 times greater than that of our parent star. And finally, the third star, VY Sagittarius, a red supergiant located 5,250 light-years away from us. It is believed to contain more than 1,500 solar radii, and the diameter of this monster may be larger than the local asteroid belt, RV, Cepheus NWO HG64. Second place goes to Silver. This place is also shared by 2 monsters, whose sizes are hard to imagine, but according to astronomers' calculations, they are real. RV. Cepheus is a fireball located in the same constellation as the holder of the 5th place on our list. Although the star is spinning 11,500 light-years away from Earth, on a clear night it can be seen through binoculars. The radius of this monster is 1,500 times larger than the Sun's, to be exact, 1,535 times. Its luminosity is 625,000 times brighter. The main feature of this object is that RV. Cephe is currently flying toward us at a speed of 56 kilometers per second. Considering that the hypergiant is most likely destined to become a black hole at the end of its life, this is not very good news. Her companion in terms of position, WO G64, is located very far from us, 163,000 light-years away in the constellation Dorado. The radius of the star is 1,540 times that of the Sun, and in our system it would easily occupy the space up to Saturn's orbit. Since its size is 2,785,000,000 kilometers, WO64 hides many skeletons in the closet, or rather, in a titanic field cloud with a diameter of 30,000 light-years. An entire planetary system, or even more than one, could be hidden inside it. But not for long. In about 10,000 years, the giant will explode and scatter everything nearby. Vi of the big dog and Yui of the shield, drumroll, and here are the 2 leaders. The first star is located relatively close, 3,900 light-years from Earth. It is about 3 billion times larger than the Sun. That's why even photons of light would need several hours to travel around this burning, pulsating monster. Today, the star is surrounded by a dense nebula, and scientists believe that some time ago Canis Majoris was a main sequence star, although more massive than ours. It weighed about 40 suns. The object is predicted to die in about 100,000 years, and the hypernova will do it so epically that its gamma-ray bursts will completely sterilize cellular life for billions of kilometers around. Fortunately, the solar system is not in this dangerous location. And here is another participant in today's top list, the last one for today, UY Scuti. This star is the largest object known to us. It is located 9,500 light-years from Earth and reaches 1,700 to 1,900 solar radii. Believe me, that's a lot. It's enough to say that in terms of volume, UY Scuti is 5 billion times larger than our Sun. If it were in the place of the Sun, we would never have existed, or the Earth would have had to move to Pluto's orbit, or even farther. At its peak brightness, UY Scuti is 340,000 times brighter than the Sun. You can see it with a powerful pair of binoculars, although the distant wanderer is surrounded by a significant amount of cosmic dust. Now you will surely understand the meaning of the saying, not only the light that is visible in the window, the universe is literally teeming with stars and clusters of incredible size. So the list we've presented will surely be revised and expanded by astronomers many times. What would you say if you found out that the Earth is flat? How would you feel if you realized that everyone around you is speaking an unfamiliar language? How shocked would you be if you found yourself on another planet? Indeed, people feel much more at ease in familiar circumstances, which is why most people don't like change. But it seems that change is exactly what awaits us, and on a global scale. We're talking about the discoveries made by the James Webb Telescope. Overnight, they undermine the very laws that our cosmology has relied on for many years. The James Webb Infrared Telescope, which only recently began its mission, has already managed to seriously astonish the scientific community. It has discovered several galaxies whose ages are too great for their existence to be possible. Moreover, one of them is even older than the Big Bang, which is, in principle, unthinkable if we rely on the generally accepted hypotheses. What could this mean for humanity, and how will it affect the fundamental laws we have believed in until now? The Big Bang Theory and Hubble's law are, as they say, the absolute basics. Most of our ideas about the macro world surrounding Earth are based on them. Every school kid knows that the Big Bang happened about 14 billion years ago. This was preceded by a singularity point, which suddenly detonated, and the universe began its expansion, which continues to this day. Next comes Hubble's law, which is the universal recession of galaxies. This is also a basic cosmological law, and it explains the very expansion of the universe. So what did James Webb do? He aimed for the Holy of Holies, trying to destroy the very foundation on which our astronomy has stood until now, considering that right after the explosion, large bright galaxies with metallic stars simply could not have formed. The telescope's discoveries are somewhat puzzling. The thing is, according to modern scientific theories, hydrogen stars had to appear first, and by exploding at the end of their life cycle, they would fill the empty universe with building materials. It was from them that more mature stars and galaxies were supposed to form later on. So how can we explain the fact that James Webb discovered CIRS 2112? This fully mature star cluster formed 2.1 billion years after the Big Bang, which is absolutely impossible if you pay attention to its density and structure. This is a barred spiral galaxy, very similar to the Milky Way, and its mass is almost 4 billion times greater than that of the Sun. Do you think that's all the discoveries? No, because there's also the galaxy AZ, TAC-71, shaped like a giant drop, which the telescope discovered in December 2023. Such galaxies have even been classified into a separate group called Hubble's dark galaxies. Scientists at the University of Texas in Austin believe that the discovered monster is a real galaxy factory, since the process of star formation inside AZ TAC-71 never stops. It is estimated that about 1,000 new stars are born in it every year. But the most amazing discovery made by the James Webb Telescope happened in 2022. This is the galaxy JATES GSZ 130. This object is the most distant ever discovered using Earth-based optics. It is believed that the galaxy formed just 10 or possibly 320 million years after the Big Bang, which is impossible. But to claim otherwise would mean not believing your own eyes and the readings of ultra-precise equipment. According to the generally accepted cosmological theory, active star formation began approximately between 550 and 800 million years after the Big Bang. And yes, these were celestial bodies mostly made of hydrogen. There was no talk of galaxy clusters or metal-rich stars. But here we have an entire galaxy that, judging by its age, formed even before the Dark Ages, a period when stars, by definition, did not exist. But the fact remains, the telescope equipment indicates that the galaxy is 13.6 billion light-years old. And if you account for the expansion of the universe, that's about 33.6 billion light-years. An enormous age, absolutely impossible. If we rely on the Big Bang Theory, this galaxy is located in the Fornax constellation. Some astronomers even suggest that it's a dark star with a mass equivalent to 1 million suns. What does this imply? If the James Webb Telescope had discovered just one such galaxy, it could be dismissed as a coincidence, but 3 objects already indicate a pattern. Besides, we forgot to mention the Henry Draper, one galaxy in the Sextans constellation, and the Z12I. At the moment, they share first place with Jade's GS-Z13-0. It is believed that Henry Draper, one may be inhabited by first-generation stars that appeared right after the Big Bang, but as the famous meme says, that's not certain. The Eye. Z12 is most likely a dwarf galaxy, about 60 times smaller in diameter than the Milky Way. Think about this as well. Considering the age of the mentioned galaxies, it turns out that their formation must have started long before the Big Bang. Isn't this the collapse of commonly accepted theories? Among all the telescopes we currently have at our disposal, James Webb is the most advanced, especially in terms of its optical system, so there is no reason not to trust its data. But you know what's most surprising and frightening? Not a single Earth-based telescope, whether ground-based or orbital, has yet discovered any young or infant galaxies in the universe, with a small number of hydrogen stars. All the objects whose photos and data are sent to us by optical instruments are fully formed, filled with a huge number of stars, and are very complex in their structure. How can this phenomenon be explained from the point of view of standard cosmology? You might ask, why rely on it at all? Isn't it possible to try to come up with a fundamentally new explanation? But the global scientific community is by no means going to do that. Its goal is to fit the obtained data to existing theories. On the other hand, you can understand them because breaking is not the same as building. However, it's not enough to just ignore the obvious. You also need to come up with an explanation for it. So, how do scientists explain the fact that there are such old, fully formed galaxies where they shouldn't exist? The first explanation is explosive star formation. This theory is meant to justify the appearance of extremely bright stars and galaxies in the deepest parts of space. In this case, a simulation created by a supercomputer comes to the rescue. As a result, it turned out that in the dawn of time, this was quite common. The theory is meant to explain the appearance of stars and galaxies. The theory is meant to justify the appearance of extremely bright stars and galaxies. The theory is meant to justify the appearance of bright stars and galaxies. Nowadays, star clusters are calm and stable, but in the past it wasn't like that. Things were different. By the way, astronomers use the term starburst for galaxies of small mass, which were the ones that formed shortly after the birth of our universe. Thus, the scientist Zalekvatsky gathered the facts and concluded that the unexpected brightness of ancient galaxies is not due to their gigantic size and density, but to starburst activity. One example of such objects is the Messier 82 galaxy, where stars are born 10 times faster than in the Milky Way. It is located in a dense dust cloud, but the advantage of James Webb is the ability to observe objects in the infrared range. The second explanation is the aging of light. This hypothesis sounds rather strange. It practically contradicts Hubble's law, which states that the universe is expanding, where galaxies moving away from us are in the red range, and those approaching are in the blue. Physicist Fritz Zwicky in 1929 tried to refute Hubble's conclusions. He claimed that as light travels through the universe, it simply ages, which causes the redshift. To put it even more simply, photons of light lose energy due to scattering in space and the influence of gravity from objects they pass by. Thus, Zwicky claimed that there is no expansion and the universe is absolutely static. For a while, the hypothesis was gathering dust on the shelves, but now it has come into the spotlight. Sorry for the pun. The thing is, the Indian scientist Gupta who works at one of the Canadian universities, decided to combine the tired light theory with the theory of the expanding universe, so to speak, reconciling their postulates. So what follows from this? The astronomer concluded that, in fact, considering the aforementioned theories, the Big Bang happened much earlier, namely more than 26 billion years ago. So the light we observe has aged quite a bit during this time. The third explanation is the theory of variable constants of nature. It's quite simple to understand. It states that the laws of the early universe and those that everything obeys now are two very different things. That is, the constants we now rely on as something monumental could have changed over time. It's also worth mentioning modified Newtonian dynamics, or the modified Newtonian dynamics theory, here. In it, Israeli physicist Mordechai Milgram tried to explain the rotation of galaxies without including dark matter in the equation. All of this together, as some astronomers believe, is meant to explain certain discrepancies between our laws and the data we've obtained. Did the explanations and theories above convince you? Did they make you doubt the Big Bang Theory, Hubble's law, and other cosmological postulates that have reigned in the scientific world for many years? To be honest, we are confused. The only conclusion we can draw from this situation is that everything we were sure of is now collapsing. Towers that seemed solid are collapsing, foundations are sinking, and floors are breaking. James Webb chose the language of facts, which are very hard to argue with or fit into convenient patterns. So for now, we suggest you take the position of an observer, grab some popcorn, and keep watching this cosmic show, while we go fetch some sizzling facts from the field of astrophysics to serve them to you before they cool down. All the best to everyone. If you think that man is the king of nature and that there are no limits to his mind, then you are greatly mistaken. The speed of light in a vacuum is just one of the many barriers that no human being has managed to overcome yet. Subtitles created by Dima Torzak, about 40,000 kilometers per hour. That was the speed of the Apollo 10 astronauts. Of course, centuries ago, these numbers would have caused a sensation, but modern humanity has a different, more ambitious goal. What is it? You may ask. 1 billion kilometers per hour. These are the numbers hidden behind the sacred phrase, the speed of light. For now, this is only possible on the pages of science fiction books and in national aeronautics and space administration computer programs. Due to the camera rolls, to be continued. Subtitles created by Dimitar Zakputi. Problem number 1 is speed. With the current laughable speeds that humanity is capable of, it would take, for example, the Voyager probe, which recently left the solar system, about 2 million years to reach a relatively close star like Aldebaran, or even the nearest star to us, Proxima Centauri, which is about 4.5 light years away. At these speeds, hypothetically, subtitles created by Dimitar, the Earth's technology would not move forward for several thousand generations. For comparison, an ion engine, under certain conditions, can reach speeds of up to 56,000 kilometers per hour. So, a ship with such an engine would take 81,000 Earth years to reach Proxima Centauri. During this time, 2,700 generations would pass on Earth, which makes the journey practically meaningless. In the case of a gravitational maneuver, the maximum speed can reach 240,000 kilometers per hour, which is just a few miserable percent of the speed of light. At such a speed. To Proxima Centauri, subtitles created by Dimitar. The number of years isn't very inspiring, is it? But even if we assume that a ship traveling at the speed of light has already been built, the forecasts are quite bleak just to travel around our Milky Way. With a diameter of 100,000 light-year subtitles created by Dimitar, it would take millennia. So how long would it take to reach our neighboring Andromeda, which is 2.5 million light-years away from us? Besides, we should keep in mind that we see it as it was many millions of years ago. It's possible that this galaxy doesn't even exist anymore, and all that's left of the nebula is the light that has reached Earth. Problem number 2 is building a spaceship that could at least partially approach the speed of light, which is still absolutely impossible. Subtitles created by Dimitrorzok. The monstrous overloads that the shuttle will have to face in deep space require super strong materials, unreal sizes, and revolutionary new fuel. For example, when using thermonuclear reactions, the ship would have to be the size of a small planet, weigh as much as the moon, and be completely filled with dangerous cargo, fuel. Building such a monster can't be done in one go. Subtitles Dimitrorzok. It's impossible on Earth. And if you try to accelerate a small shuttle to the speed of light, it would require as much energy as all the Earth's sources produce in a month. Scientists are considering the option of using antimatter. An engine running on such fuel can accelerate a ship to a speed of 70% of the speed of light. But in this case, there are even more problems. First of all, the process of annihilation, the interaction of matter with antimatter, releases an unreal amount of radiation. Therefore, nothing alive would survive on board this ship. Secondly, there's the problem of storing such fuel. Any slightest contact with the ship, and disaster would occur. Subtitles created by Dimitrorzok. The process is too expensive and the result is extremely short-lived. A milligram of positrons costs $25 million and lasts for about 20 minutes. Desperate scientists are also visited by subtitles created by Dimitrorzok. People inside an asteroid, which for many dozens of generations will travel in cosmic silence toward the nearest star, rotating around its axis. But there is a danger that over several thousand years, people will simply forget why and where they are flying, and won't even remember who they originally were, and the story of the journey to the star will turn into just another legend. Problem number 3 is the harshness of space. The vacuum is not empty at all. Like the likes under this video, subtitles were created by Dimitrorzok. At high speeds, they will turn into a deadly threat to the intergalactic Voyager. Even at 20% of the speed of light, hydrogen atoms and cosmic dust will seriously bombard the ship's hull, and the speed of light itself would simply destroy the vessel along with its crew. The force of the impacts would be comparable to a beam of protons accelerated by a hadron collider. No material could withstand such attacks, not even in theoretical hypotheses. Subtitles created by Dimitrorzok with radiation, but the shield would have to be hundreds of meters thick and weigh several hundred tons. Everything we know about this world ends sooner or later. Joy, suffering, love, a long road, an interesting journey, human life, this video, and the vast universe. Although, wait, it seems we might be wrong about the last one, or are we? Astronomy has answered many questions that have interested humanity. Thanks to this science, we learned that the Earth is round, the Sun is a huge hot ball, and there are billions of similar stars in the macrocosm. But scientists are still unable to determine whether the universe has boundaries. Astronomy is left with only speculation on this topic, but even these thoughts can overwhelm unprepared minds. To begin with, think about what infinity is. In the case of the universe, this means that neither its size nor its mass nor the time of its existence can be expressed by any numbers, not even incredibly large ones. In traditional cosmology, there are 2 important points. If the macrocosm is finite, it cannot remain in a stable state. The universe will either contract or expand, and expansion is what we are observing now. The second point is that if space is infinite, all these actions simply lose their meaning. So how do we deal with that now? Probably due to these cosmological postulates, scientists' opinions have become seriously divided. Let's voice the most popular ones. Theory 1, find your copy. Let's start with the most incredible one. Let's assume that the universe is infinite. Then the following law inevitably comes into play. The fact is, within a certain volume of space, there is a limited number of particles and their combinations. For example, in the observable universe, there are about 10 to the 80th power of them. This number is so enormous that it can't be written down using all the pencils available on Earth. But that's far from the limit. If you go deeper into space, the number of configurations will increase, but again, only up to a certain point. And when, figuratively speaking, the Rubicon is crossed, the traveler will start to notice familiar places more and more often, vaguely reminding him of things he has seen before, until finally, a person discovers a duplicate of the solar system, Earth, and eventually a copy of himself. And that's the most incredible thing that can happen in the space-time continuum. Does that mean the universe is still finite? Probably yes, many orthodox astronomers will tell you. After all, a closed state is much more convenient, since it doesn't disturb the laws of physics. Version 2 size matters. So, for decades, scientists have been unsuccessfully searching for evidence of the existence of the boundaries of the universe, or their absence. The logic behind the search is this: if space is closed, then by looking closely you can find identical locations on both edges of the sky. But no matter how much astronomers have looked for such similarities, there are absolutely none. At the moment, the diameter of the universe, due to its constant expansion, is 90%. Perhaps this is only a small part, but it is exactly what we are able to observe. If you measure this in kilometers, it turns out to be an unimaginably enormous distance. And surprisingly, in not a single galaxy or nebula across the entire observable area can you find repeating fragments. This fact allows us to conclude that the universe is not closed, but this statement will be true only if its size is small by astronomical standards. Based on this, a certain group of astronomers strongly advocates for an infinite universe. Multiply the third assumption by millions. But no, says another scientific conglomerate, it is closed. Let's try to argue this opinion as well. It's a known fact that the deeper we look into space, the older the locations we observe. Moreover, we don't see them as they are right now, but as they were thousands, millions, or even billions of years ago. But besides stars, galaxies, and clouds of gas, astronomers from Ukraine study the early light of the universe called the cosmic microwave background. It contains a wealth of information. In particular, it was its fluctuations that helped determine that the world around us is an absolutely flat space. Supporters of this theory are convinced that the universe is finite, but the scale of its structure is so impressive that we are unable to determine how and where the universe closes in on itself. It is believed that it is at least 250 times larger than the space that humanity is able to observe. This results in an enormous number, at least equal to 11 trillion light years in any direction. And that's according to the most modest estimates. Our pygmy scale is incomparable to such an enormity, and as a result, people are unable to see the true state of things and realize the finiteness of the megastructure. National Aeronautics and Space Administration would like to say a few words. The specialists from the famous space agency confirmed the theory about the limited size of the universe, but approached the proof of this assumption from a different angle. They also became interested in its fluctuations, carefully studied the data obtained from the American probe Wilkinson Microwave Anisotropy Probe, and found that on a large scale, fluctuations in the microwave background are practically absent. This not only indicates that the universe is finite, but also proves that it is relatively small. That is, we're not talking about trillions of light years, but only about 70 billion. Therefore, in such a closed and, by macroscopic standards, small space, extended fluctuations simply cannot arise. Obviously, scientific pluralism is progressing, and it's unknown what else scientists will come up with. The presented hypotheses do not allow us to fully understand which of them are correct, or at least closest to the truth. For now, the question of whether the universe is finite vaguely resembles the rhetorical riddle about the chicken and the egg. After analyzing the most popular hypotheses, it can be said that most still lean toward the more familiar option of a finite structure. Maybe you have your own ideas about what a finite universe might look like. Share in the comments how you imagine it: a giant closed torus, a Klein bottle, a Mobius strip, or something even more incredible. And at the same time, don't forget about likes, reposts, and the magic bell that lets you be the first to get updates from the Hubble channel.